Good evening, everyone. Okay, good evening, everyone. My name is Riya Sharma. Today, so this is the week 3 lecture of thermodynamics of fluid phase equilibria. My name is Riya Sharma. I should also write this. Wait. I am a PMRF candidate of Cycle 11. I did my bachelor's from NIT Nagpur, and now I'm pursuing my direct PhD from IIT Kanpur, and I'm a chemical engineering student. So I'll be taking your week 3 lectures. The previous 2 lectures were also taken by me, and I have uploaded all the videos on YouTube as well as given the reports to what we have solved. If you have any doubts, you can comment on YouTube, or you can mail me personally, or you can mail on that NPTEL uh, discussion forum. So the practice will exactly be same. Number one, that I will be giving you the questions. I'll be mostly trying to relate all your assignment questions and my own made questions, and I'll be also telling you, and I'll be taking few assignment questions of yours. Generally, I start with taking 1 or 2 assignment question to build up. Okay, fine, these are the ways how you have done and how I am doing. You can guess how is it done. Number two, I will also be taking some alterations, but the concept and the similarity from your assignment questions will be same. The in-depth lecture 3 was on fugacity. You were introduced with fugacity concept, and for real gas, for normal gas, enthalpy of mixtures, how it is done. So it will be carried out in your week 3 lectures. And so I'll be waiting for 2-3 minutes so that if one person can join, I'll be giving that much of leverage that everyone should join. And then I will start with this first question. Whosoever has come till now can note this question, and you have this is basically your assignment question number 4. So you can start doing that, and we will wait for 2 minutes. After we will solve the questions. Try to write all the things which are given. Try to know what it is, like how to solve the problem, and mainly the formula which is important, the concept which is important. If you are able to click that concept, the question is just a next step. So the major thing is you click the concept, you have written to like write all these 3 things, and you will be solving those problems. Okay, so bring your laptop, bring your calculators, because these are numericals which we will be doing, and you can start doing this assignment question number 4. And I hope you must have gone through this question. And lately there are some network issues which are there, so I'll be putting my video off in a while solving the problem, because otherwise it will have lag in it. Rest we will start doing it in 1 minute. Okay, so given you the question number 1, it's taken from your assignment question number 4. It is saying estimate the fugacity of, so for highlighting I'll be using red pen. Okay, so it is saying estimate the fugacity of butane at 330 Kelvin and 20 bar. The fugacity coefficient is 0.85. Okay, so let's try. Let's try to solve it. So the answer, what has been given to it, what is fugacity coefficient? Just remember that phi equals to 0.85. And here the concept I am highlighting with the yellow. So the concept which says is, what is fugacity? It is for real gases. We have introduced fugacity, or the fugacity of any gas is given by an expression of a gas is given by phi equals to F by P. Okay, so you just have to use this thing. Now let's see what is given now to us. You have been given phi, you have been given the temperature and pressure conditions. Pressure is equals to 20 bar, and what they are asking, what is the fugacity? So fugacity is basically, they are asking what is F is equals to. Can we solve this? Let's try putting these values. We now know F by P. This is the condition which is given to us. And this is what is asked. Now can you relate what is phi? That is fugacity coefficient. So can we now try to say what is fugacity F from this thing? F will be equals to phi into P, which implies F equals to how much phi was? Phi was 0.85, and if I'll multiply it by the given temperature or the given condition, it is 20 bar, I guess so. Yeah, I hope this is clear. So yeah, you just cross verify this is 21 and it is given. So this is given to us. Can you find out now what is F? I guess it is easy. It is equals to 17 bar. So if I'll just say this is our answer. Take 2 minutes of revising that. What we have done, we have taken the concept of fugacity, that fugacity coefficient is equals to the real F fugacity divided by the condition which is given to us P, and then we have just applied what has been given to us. So I hope you are good to go with the question. So now I'm till the time you are doing reading this question and understanding it, I'll be writing one conceptual question. Okay, so yeah, so I hope you are clear with the first question. So the answer, now you can see the answer is A here, 17 bar. So what we have applied is phi equals to F by P, and we got P was already given to us. We use the fugacity coefficient, which has already been given to us, and it was asked what is the fugacity of the butane. The second question is, so this is conceptual question which I have asked you. It is throttling. The throttling process is what? Like, is what kind of process in which or you can just say a throttling process is a process in which dash is constant. So it's a constant some function process. So the question says, what is it? Is it a constant entropy process, enthalpy process, a pressure process, or none of these? So this is a very basic question which I have asked to you. You should always remember that the enthalpy, when the Joule-Thomson effect, when we talk about the the TS curve, when we do, it's always a constant enthalpy process. Joule-Thomson effect is a constant it's always a constant enthalpic process. Okay, now I want you to write one question with me, which is made question from me, so we can write together this thing. This is a good question, I feel, so let's write it. The enthalpy expression for binary liquid mixture is H equals to 400x1 plus 600x2 plus 40x1 plus 60x2. The partial molar enthalpy can be expressed as H1 is equals to H plus 1 minus x1 del H by del x1. The final expression in terms of x1 is So there are 4 options given to you. 400 plus 60x1 square plus 40x1 cube. B. 400 minus 60x1 square plus 40x1 cube. C. 420 plus 60x1 square plus 40x1 cube. D. 420 minus 60x1 square plus 40x1 cube. So let's try to solve this question. So the expression which has been given to us is this one. So the enthalpic expression which has been given to us is this, and they have also told us that the partial molarity is the partial molar enthalpy is H1 del H by del X1. The final expression in terms of X1 is. So we have already X1 bar, which is, so you just have to hint can be one thing that first of all you can try solving by your own, then we will solve it together, but everything, the expression is given to you, and take 2 or 3 minutes to solve this question, and then we will solve this question together. You have already been given what is H, so I'll list it out, few things what we have given and what we want. So you can also start doing by yourself, and this is similar to the question number. Okay, so in your question, that is similar to your what do you say, the question number 8 of yours. Basically it has some volumetric question which has been given to you, and here it has not been given your volumetric thing. So what we already know, so I should also always start writing by that. 400 x1 plus 600 x2 plus 40 x1 plus 60 x2. Okay, this we have been given. Another thing which has been given is the h1 bar is equals to h plus 1 minus x1 into del h by del x1. Okay, so there is one beautiful thing which you have to see now. In my expression, where I will be also writing the concept, there is x2. So there are two expressions, x1 and x2. So what we actually want, or I will say it is not a concept but crucial step, is we already know that the molar fraction x1 plus x2 is always equals to 1. What it has been asked from us, what is asked from us is we want enthalpy, or the final expression we want in terms of x1. So what we should do, we should remove the x2 from the, we should try removing the x2 from the enthalpic, like from the enthalpic equation which has been given to us. So that's why I said this is a crucial step which you have to take. So what we got x1 equals to 1 minus x2. So what does this mean? If I, another thing, we have a differentiation term here. You can see we have a differentiation term here. So if we will differentiate, we will get a del x2 terms also. So basically we want a differentiation. So differentiating both the side, I'll say it will be dx1 is equals to minus dx2, which implies dx2 by dx1 is equals to minus 1. We will keep this aside. Okay, now let's focus again on the question. Now it has an expression, so we start to solving. From solving, yeah, say it is like solving. Now it has a term of del h by del x1. So we will solve that as first step. Okay, so first step we will do. So how will del h by del x1 will come out? It will be 400 minus 60. So shall I write that right now? Okay, I should, for a better clarity, I should do that again. Okay, so we have, what we had was h equals to 400 x1 plus 600 x2 plus I guess there is some x1 or x2 mistake, or x1. So there should be one x2 as well, I guess so. Yeah, because it is del h by del x1. So it will, I guess there is an issue on the printing side, that there should be 40 x1 plus 20 x2. Yeah, so this we already know, and we also had, yeah, so continuing that, so how much this del h by del x1, we were doing it right. Yeah, so how much this del h by del x1 will become? It will be 400 minus 60 del x2 by del x1 plus x1 into x2 into 40 minus 20 plus 40x1 plus 20x2. This is x2 minus x1. So how much you will get in total? Just try arranging stuff in terms of like all the numericals and all in one side and the other things in other side. So that will become approximately 40x1 x2 minus 40x1 square plus 20x2 square minus 200. And since we know h1 bar is equals to h plus 1 minus x1 to del h by del x1, which will be equals to 400 x1 plus 600 x2 plus x1 x2 into 40 x1 plus 20 x2, and taking 1 minus x1 into minus 200 plus 40 x1 x2 minus 40 x1 square plus 20 x2 square, which implies 420 minus 60 x1 square. If you will do this by yourself, you will get this. You will get h1 bar is equals to 420 minus 60 x1 square plus 40 x1 cube. I won't do everything like, but you just have to put these expression again. So I have given a shorter way to do that, but if you will start solving by your own self, you will get what the exact expression is. You can take a bit of time to understand this problem. You can go from del x, try finding out first of all, this concept is crucial, that we know that mole fraction summation of both the species will come around to be 1. So we will take del x2 by del x1 equals to minus 1. So we have already taken del x2 by del x1 by equals to minus 1. So here we will put this part equals to minus 1 I have taken, and then you will try solving it out. Okay, and just putting the del h by del x1 value in this equation we had for h1 bar. You can take 2 minutes of time to understand this thing. By that time I should ask a very fundamental question. Okay, so it's been 2 minutes now. Let's see what is the answer of our h1 bar. I hope everyone will get to be the answer as minus 420 minus 61 x cube and all that. So this is the answer. So you just don't have to do any more things in general. It is basically learn my video first. Yeah, so you don't have to do much about it, you just have to solve systematically, and you should know where the concept of x1 plus x2 equals to 1, which we already know. And the second crucial step was that the summation was equals to 1. So the differentiation, because at one point if we see, we got del x2 by del x1, which we have substituted that as, which we have here substituted minus 1, substituted minus 1. The other thing was just putting the del h by del x1. Anyone can do by anything. I started solving in a pyramidal way, like I have solved in the stepwise way, that I've solved del h by del x1, and after solving del h by del x1, I have put the enthalpic equation summation into 1. So now coming back to question number 4, it's another question which is a conceptual question. I'll put it as a conceptual question. Okay. You should know this, and the reason also you should know this. So for an ideal gas, enthalpy change of mixing is how much? So when two ideal gases mix, does any enthalpic change happens or not happen is the question. If it happens, what is the value? If it doesn't happen, what is not the value? You can take 1 minute of thinking. Like generally think about assumptions of ideal gas. Like does it have interaction? Does it interact with it? Because the first assumptions when you think about ideal gas, you say that there is no interaction as such. So when you mix two ideal gas, will there be an enthalpic change? Will there be enthalpy change, or the internal energy will, because H is equals to U plus PV. So is it the internal energy change will come or the enthalpy change will come? No. It's a basic answer, which is 0. So answer is A, 0. There is no enthalpic change of mixing. Okay, let's dive back to question number 5, which I have made for you. So can you write with me? Can you all start writing with me? The question is, the expression for fugacity is ln f by p. This is ln f by p equals to 1 by RT 0 to p alpha dp from the PVT diagram or data for a gas. It is found that integration of 0 to p alpha dp is equals to minus 556.61 joule per mole. Find the fugacity of the gas at 50 bar and 300 Kelvin. So please, first of all, see the question, what has been given to you. First thing which has been given to you is the expression of this thing. The second thing is from the PVT data they found the alpha dp, the summation of integration of alpha dp as given to be as minus 556, and they want fugacity. So You can try doing for like take 2 minutes of understanding the question, and then we can start writing the solution. So what is given to us? I'm just writing what is given to us. You can start solving by your own. Isn't it a very straightforward question if you'll just see that the expression has been given to you? You just have to put the values and you will get the answers, because everything has been given to you in a way. It has been said that what is the value of fugacity, and you just have to put the alpha dp value inside it. So can you start thinking by yourself? You have been given. So one more thing, you can just know that what is the value of you should also know what is the value of r, and then you can start solving the question by yourself. So this is also your assignment question number 10. Question number 10 question. So let's start doing this question. So we just have to put these value. P is equals to how much it has been given, 50 bar minus 1 by 8.314 joule per Kelvin. This is 300 Kelvin which has been given to us, and this value is minus 556.61. So can you guys try solving this? So this is equals to, this has no, yeah. Can you solve this? My calculator, after solving this, I am getting around this value to be around 0.332. So you just have to take the exponential to it, taking exponent both the side. So this will be f by 50 and this will be e raised to the power minus 0.2332, and you just have to find then 50 into, okay, can you solve it now? How much value do you get? I will get around approximately 39.998 bar, which is equals to 40 bars approximately. So you just have to put all the formulas into one and you can get the solution. Now let's go for question number 6. It is similar to your assignment number 2 question. Similar concept. Okay, so can you start writing with me? Was saturated liquid at 1500 kilopascal 500 Kelvin with an enthalpy of 750 kilojoule per kg is throttled to a liquid vapor mixture at 150 kilopascal and 300 Kelvin. At the exit conditions, the enthalpy of the saturated liquid is given you take the value only is 500 kilojoule per kg and the enthalpy of the saturated vapor is 2500 kilojoule per kg. The percent of original liquid is which vaporizes is question mark. So how much? So the first value is 87.5%. B part is 67.0%. C is 12.5%. And D is 10%. So you can try solving by yourself. It is very important that you write what is given to you and what all things has been given to you. If you know and what it is said. So the question number 4 which we have asked, or sorry, question number 2 which I asked you, when it is said that throttling is a constant enthalpic process, so here we have to say that it is saying that it has been throttled. Very important thing. And it is saying, so when it is throttled itself means that it will have constant enthalpy. So if we know that it will have constant enthalpy, and let us assume that X is the mole fraction of X is the mole fraction of liquid, then can we find X? And from that we can find the fraction of liquid which vaporizes by using 1 minus X concept. So I'll just the enthalpy will be constant. So H1 will be equals to the enthalpy. So if we can say the enthalpy of mixing, so if I know H1 we know that the saturated vapor enthalpy is 2500 kilojoule. So what you have is, so let's say X is the mole fraction of liquid. So at that condition, we have been given that 750 kilojoule per kg is the enthalpy. Equals to the total enthalpy. So basically, can we write 500x and the vapor will be equals to 2500 will be equals to 750. These value has been already given to us or not? You just have to find x. Can you do it by yourself? And then after doing, there is one important concept which you have to apply. And then start it. So I hope now you are able to solve the value of x. The value of x will come around. So let's try to now solve it by ourselves. 3000x minus plus 2500. So we just take it as it is. 500x plus 2500 minus 2500x equals to 750. So minus 2000x will be equals to minus of 750 will be equals to 750 minus 1750. If you'll cut the minus sign, if you'll find the value of x will be almost equal to, or will be exactly equals to 0.875. But the question to find is, so don't just write 8.75%. Like many will say, oh, A is the answer. But this is not the one. It is what they are asking. They are asking one thing, that how much of the original liquid. So original liquid how much it is vaporized. So it will be equals to, so 1 minus x will be the vapor part, will be equals to 1 minus 0.875 to 0.2125. Okay, so percent of liquid vaporized will be equals to 0.125 into 100 is equals to 12.5%. How much? What is the answer? Answer will be C. So don't get overexcited. Like if somebody is not able to understand this, think in that terms that it is fine. How much? So in a mixture, there's a liquid and there's vapor. There's liquid and vapor. So how much the part of vapor which is left will that much amount of liquid which has been vaporized. So that's why 1 minus x concept has come. So I will also write good part is this. Crucial step is this. So there are two important concepts. There are two concepts we have to remember. First is throttling. So H1 will be equals to H2. So just you have to this part and 750. So this is like already given at t equals to and t and p. If I'll say t1 and p1, it was already given to us, and liquid and vapor has been separately given to us at t2 at p2. I guess so, yeah. 150 kilopascal, 300 Kelvin. So their mixing value and this total value we have equated, and we found the value of x. But x will be the liquid that is left, but the almost all the vapor which has been given out will be called as 1 minus x. Okay, are we good to go? So take another question with me. This is question number 7, I guess so. Yeah. So it says at constant T and P, the molar density of a binary mixture is given by P equals to 1 plus x2, where x2 is the mole fraction of component 2. So it is asking the partial molar volume of component 1 at infinite dilution will be how much? Is how much? So it is finding basically V infinity equals to how much, right? So the options are 0.75, B is 1.0, C is 2.0, and D equals to 4.0. Do we have a similar question or not? Let me check. Yeah, we have it. Similar Question number 9 of assignment. Similar concept. Okay, so you can start thinking about it and start doing by yourself. Take 2 minutes and then we will start solving it. So are we good to go with it? So what it has been asked to us, so just write these things that this is actually the row. Honestly, this is the row. Okay. Let's go to the answer. So we have already been given that rho is equals to 1 by x2. Okay. And this is they are asking for component 1, right? They are asking for component 1. So if you'll see what they are saying, that the rho is given by this, and find me the v infinity. What will be, I'm sorry, you can put this as top also. V infinity equals to how much? Yeah, so it is asking us. So as you know, as we already know, that it is molar volume. Okay, sorry, it is molar density. Right? So molar volume, if we will say, will be 1 by rho. So isn't it an important concept? So what will be the molar volume will be opposite of 1 by rho. Okay, what is rho? Rho equals to moles per unit volume. So this is per so for single mole, like for 1 mole, so it is said for 1 mole, so this is molar means 1 mole. Also we know that for binary mixture, the mole fraction of component 1 will be equals to 1. Yeah, so now is it, so therefore V is equals to 1 upon 1 plus x2 I'm sorry, yeah, going back to the work, yeah, V equals to 1 by rho this is to 1 upon 1 plus x2, making x2 in x1 terms, because we have to find v1 infinity, right? So v equals to 1 upon 1 plus 1 minus x2, sorry, x1, 1 upon 2 minus x1. Now let's differentiate. For differentiate, so it will be del v upon del x1, which is v equals to 1 upon 2 minus x1 whole square into minus 1 so you can just take it as it, so which implies del v by del x1 will be equals to 1 by 2 minus x1 square. Okay, now we know that v1 bar will be equals to at infinite things, so it will be del v by del x1, which will be equals to we already know, plus x2 but we will take this as 1 minus x1, right? So this will be becoming 1 minus x1 upon 2 minus x1 square will be equals to, take 2 minus x1 square as in denominator, 2 minus x1 plus 3 minus x1 which will be equals to 3 minus 2x1 upon 2 minus x1 square. Now we want for at infinity will be equals to limit of x1 will tends to 0, because dilution means this. v1 will be limit x1 tends to 0 equals to 3 minus 2x1 upon 2 minus x1 square is whole, right? Will be equals to 3 by 2 square will be equals to 3 by 4 will be equals to v1 equals to 0.75. This is your answer. Did we have 0.75 as answer? Yes, we have. So this is answer equals to A. So what are some crucial steps in this? Let's see that. There is one crucial step, formula, which you should remember because it is like V plus x2. Molar volume we knew, so we already differentiated it. So we just have to put del V by del x1 in this, and we just basically write a formula of that. Are we good to go? Yeah, I hope. Now when we will revise, we will do it. Now let's come back fastly to the third question. Oh, sorry, the 8th question. Let's write it. The residual volume alpha is given by the relation as alpha equals to RT by P minus V. Then find out the relation for del P by del V at constant temperature. The result is expressed by the empirical relation given as alpha equals to 2 minus 3 into V square. Okay, so this is our question. This is similar. Is it similar to it? Yeah, it is kind of similar to your question number 8, but not exactly. So let's try to solve. So we given to us alpha equals to RT by P minus V. Okay, where alpha equals to 2 minus 3V square. What we have to find out, so these two things are given to us. Okay, what we have to find out, we have to find del P by del V constant. So just like, let's not make this as a confusion, so that's why I'm changing this to capital V. Okay, and here also again this is 2 by 3 V square. Yeah. So this is del V. Take 2 minutes of time to solve it, and then we can do it. It is just basic rearrangement of formulas, which you can for sure do that. Take few minutes, and then we will start doing. Yeah, so I hope you are able to try out this thing. So if you have some issues, you can follow my steps. So as you already know that alpha equals to RT by P minus V, which implies alpha plus V will be equals to RT by P, which also implies that P, so basically we want P in terms of V. So how can you get that? RT by alpha plus V, where we also know alpha equals to 2 minus 3 by V square. So put that, so putting that RT upon 2 minus 3 by V square plus V. So if now, so let me just write, P equals to RT V square upon 2V square minus 3 plus VQ. Now you have to do del P by del V at constant temperature. So nothing, just V cube square and into minus 1, minus 1. Now just take this will be RTV, and what you have to do is V cube plus 6. I hope you are able to do. So if I'll say del P by del P, it's a basic in differentiation. In proper words, if I can write this is 2v square cube whole square. So this is the answer. Are we good to go? Well, that's so nothing we did. We have just substituted. They were already given things. We have the values, and we just put these values into it and try to solve it. So it was an easy question. Now let's take another question. Right. So the question is expression for the fugacity coefficient for the gas obeying the equation of state P into V minus B equals to RT is. So taking this ahead, the options are P, B, P, RT. The second option is exponential of BP by RT. C option is ln BP by RT. And the last option is RT upon B minus B. You can take 1 or 2 minutes to understand the question, and then we can write it. So expression for the fugacity coefficient. So it's basically asking the phi. The phi. How much will that phi be? And phi is generally equals to ln of f by p. And the equation of state which they have already given to you, it's this. So you can try striking the question for 2 minutes. Then I will solve if you have any issue. So yeah, start by what has been given to us, the equation of state. So the given thing is equation of state is equals to v minus b equals to RT. So if I'll just open this thing, it is PV equals to RT plus PB. So divide whole equation by RT. So PV by RT will be equals to 1 plus PB by RT. As we know, PV by RT can be written as Z. So basically, substituting that, Z equals to 1 plus PB by RT, or you can also write Z minus 1 equals to PB by RT. Okay. So now have the question come. Important part is concept is we know that fugacity coefficient is equals to ln of f by p is equals to ln of phi is equals to 0 to p z minus 1 p by dp. And this we know already. So with nothing we have to do, we want. So if we know this thing, now it is very easy. We just want to z minus 1 by p is equals to b by RT. So integrating both the sides from 0 to p. Okay. So integration of 0 to p z minus 1 by p is equals to 0 to p b by RT, and there has nothing been given, so this can be written as ln of f by p will equals to, we can put b by RT into p, so we can just write this thing PB by RT. So you can just take this as answer. I hope you. So important part was one was this thing where we have used this thing. We know that Z is equals to PV by RT, and when we did that, we did Z minus 1 by P into B by RT, and we integrated. We already get all the things. Yeah. Now a very small last question. So this is question number, what shall I take? Okay. Question number 10. When P tends to 0, the fugacity of pure gas. So this is basically the question. So I think so it has some issue. So I'll just, this is, so the question was from assignment 1 basically. So rather than writing it like that, I can just normally so I can normally just write that so I can just revise you all. The question was like when F tends to 0, so P for pure gas P tends to also 0, so phi will tends to P. That was your question number 1 of assignment 1. So rather than going into that deep, I will just overall give you so overall we'll give you that we in the first question we did estimation of gas, fugacity gas, then by using the question basic, what is F by P, okay, and I'm still right. So yeah, that question I was telling you was on fugacity concept. Yeah, so on the first question which we did, okay, now it's fine. Yeah, so the question number 10, I'll just conclude that when P tends to 0, the fugacity of pure gas is F tends to 0, B F tends to P, C F tends to phi by P, and D it is F tends to infinity. So this is also your assignment question number 1. Okay, so this is an easy question, very that when for pure gas, as P tends to 0, it's a basic concept which we know, the phi always tends to P. Which implies F will be question. So revising the stuff which we have started with, a bit of I have diagonalized that. So we have taken the first question on the concept of phi equals to F by P. So phi equals to F by P we have to find out, and you found out the first question. This is like the enthalpy is the Joule-Thomson effect which comes into the picture, where we wanted here there was an important question of x1 equals to 1 minus x2, and the differentiation is also an important parameter of enthalpy. Ideal gas has 0 enthalpic value, which is to be noted out. Here you just have to put the values and give the answers, so there's nothing like just given everything and given and solve question. Sixth question was a good question, where first of all it was given that throttling was a process, and we knew that enthalpies are similar, so we just equated the enthalpy, and the crucial step was that how much vapor has evaporated. The question was how much liquid has evaporated, so we did that. Now V infinity, it was the another question where you need to know how the V value varies, and the another thing was that x1 equals to x, and what is the molar volume of this problem. It is just given and solve question where we just differentiated it and everything. And here the formulas of Z minus 1 by P by RT, and the 10th question is on your F tends to P question. Okay, so I hope you guys have gone through every question and you got it. If you find any problem, you can post the comments. I will also upload all these upload all this document as well as the video on YouTube channel, and yeah, that's it. So we will meet next time with week 4. I hope everything is good now. Thank you so much.